Customers will often ask, what is an interferometer? The interferometer is the beating heart of the FTIR instrument. In the traditional FTIR interferometer, there's an infrared source, there's a beam splitter, there's a fixed mirror, and there's a moving mirror. This assembly here changes the optical path difference of the infrared light. So infrared light can take this path, infrared light can take this path. It's the interference of this light which produces what is known as the interferogram, which is the raw signal measured as part of the infrared measurement of a sample. Now in this design, the optical path difference must be changed to cause interference by this linear moving mirror. This moving mirror moves along a track, reflecting infrared light back. An inherent flaw of this design is that mirror can undergo what is called tilt and shear. Tilt and shear is simply misalignment of that mirror as it moves along that track. That misalignment reduces the intensity of signal at the detector, and additionally can introduce noise, random measurement noise in the measurement. For some years now, PerkinElmer has employed what is known as the DynaScan interferometer. In the DynaScan interferometer, the infrared light comes from the infrared source to the beam splitter off the fixed mirror, and a portion of that light also travels through the pivoting mirror pair. The use of this pivoting mirror pair prevents misalignment. In fact, the DynaScan interferometer is immune to the effects of tilt and shear. Why is this important? It's important because the elimination of those artifacts actually improves the scan-by-scan measurement quality, allowing you to address challenging analytical measurements with confidence in the quality of your results.